Okay, give me a second to get the video up here. Because we were outside, I didn't set this up yet. So a couple quick things before we get going. I wanted to let y'all know that the syllabus stuff I told you before, right? So I'm gonna give you, in just a second, I'm gonna give you your syllabus and you'll have that. Come on, you, open up. Yeah. Still too tight, come on. There it goes. Okay. Okay. Take too long. Okay.
Liam's in the waiting room.
Ah, good. Okay. Oh, it's not turning on. Oh, I know. Hold on. This whole thing is not. Look, that's here. What? Very distracted this morning by people. Come in.
Oh.
It's not great. Why is it like that?
Oh, so.
But yeah, what's the problem?
Bye.
Don't see the issue.
Jack, if I want to get all of them free.
Why aren't you turning on? Okay. Do you not have power? You should have power. What's the deal? Oh, here we are. Okay. Sorry, my iPad was like not gonna behave for a minute. I don't know why.
There was like.
Here we go.
How close are you to get to Ronald? No, like I walked across this little wetland area, and then one step, my foot just went whoop, and it was like up to my legs. There was like things moving around. I could feel it. Although my skin is super smooth now, but I probably did get like some disease.
It's funny. The skin is super smooth now.
It is, but the mud smells so much like sulfur. It wasn't good.
Gross. Here we go. Good gracious. Oh, why is this being like this? Hold on.
I also lost my shoe temporarily when I got out, and the instructor and like big, and like it took a while. My friend who told me to go across there, who said I saw you sink, but my brain wasn't fast enough to compute, so he also fell in. He permanently lost his shoe. Like it's gone. It'll resurface like in 100 years, and people will be like, "Man, what happened there?" Someone get abducted, and who knows? Maybe something.
Maybe.
Maybe.
I mean, it would be a pretty decent spot to hide a body.
You got it. Hey, sorry it took a minute, Liam. We were all outside and it's frozen. I don't know if I'm even muted. I'm not talking. All right. So, a couple quick things first. I want to pass out to you all the
Still says admit.
So says what?
Still says admit.
No, it's not in. Sorry. Okay. Yep. Yep.
Hello there.
Hello. There he is. Apologize there, Liam. We were trying to get everything set up and we were outside in the freezing cold doing our lab. So took us a minute. Now we're here. All righty. So a couple quick things before we start. I'm going to hand out to you your syllabus for the next quarter. When you come next week, I will give you your the rest of your quarter's worth of paperwork. I have it already. Like I said, it's already in Dropbox. You can access it if you want to see it. There's just no way for you to for me to print it because I'm out of the weird thing. So let me hand these out. So Jack, you were saying when you were camping, you got your foot stuck in the mud.
I did.
Did you wreck your shoe?
Well, like people told us like bring exclusively sneakers, and I didn't have those. Like that could get like destroyed. We went to Walmart, and the cheapest pair they had in my size was like pure white shoes. But they were made out of such fake leather and plastic. Like once you wrenched them off, they were like perfectly white
Yeah,
again.
Walmart ones are good when
Yeah.
you're planning on ruining them. Yeah,
Yeah.
they're perfect for that.
But the inside was like this story. I was there like scooping out my shoe because it was full of mud.
Then
I lost 2 socks.
is that it?
It was a like slightly traumatic experience.
Drama.
Like I have PTSD of like sleeping now, like last night, I was like, oh,
All right, let's see. So you reminded me of, so my favorite movie still today is Goonies, always will be.
it's a great movie.
It is, it's timeless. I can still watch it as a full grown, well, I guess I'm an adult, and it's still freaking amazing. So anyway, when I was a kid, we had these bike trails in the back of my neighborhood that these people had really worked on. Like they had, it was pump tracks and there were hills and it was great. And there were no hills in Virginia Beach because it's all at sea level. So when you found a hill, it was kind of a big deal, right? And so we were not allowed to go back there by ourselves because that was my mother's rule. But we went back there by ourselves because it was fun. Yes, as one does. And so I was feeling very adventurous, having watched Goonies for the 9,000th time. And there was a marsh behind this is just the end of a cul-de-sac, but there was a marsh behind it. And I thought, well, I'll just jump from, level spot to level spot and I'll be fine. So I did what you did. Like I jumped and my whole foot and my sneaker went down into the water. And this was winter, guys. It was like February. I mean, there was actually there were ice crystals in the marsh. So I picked my foot back up and my sneaker filled up with this muddy ice cold water. And I had a sock. So I put my other foot down and the same thing happened. And then my feet were wet and they were so physically so cold that I could not get back on my bike. Like I didn't know what I was going to do. I couldn't pedal. And my cousin, who my mom calls the town crier, she had no qualms whatsoever with pedaling back to my house and tell my mom that I was stuck in the mud in the woods where I wasn't allowed to be. And my best friend was with us. So it was my best friend, my cousin, and me. So my mother drove to come get me, which, as you can imagine, was not great. And she pulled up and I thought, if I live through this experience to tell the story, she doesn't kill me. So she picked up me and my frozen feet and I got back to my house. And then she told all three of us, this is where it gets good. She told the three of us to go into my room. So we all go into my room and like, I don't know if you've ever noticed, but there's like a desk with a hutch in the guest room. And there's a little place where the chair slides under. That's my desk. Like it was my furniture. So we were all in there and my best friend went and hid in that little space. Like she curled up in the space where you tuck your chair in because she was so scared that my mom was going to kill us all. So I got reamed up one side and down the other and restricted. And I don't even know what else. And the fear of God put in me. And yeah, he's a sap. And my cousin got pretty much the same thing because, she's my mom's brother's kid. But my best friend, she came to get her. And this is the best. This was in the late 80s when you could discipline other people's kids.
Yeah.
So she came to get my best friend and her name's Shannon, but we call her Ducky. We've always called her Ducky. And so she walks in and she's like, Ducky, come here. And she's, and my mom's like, Shannon. So she tiptoed out, absolutely terrified, went off with my mom. And all my mother said to her was, don't you ever go in those woods again or do something you're not allowed to do. That's all she said. My best friend was in tears. She still remembers it as like one of the scariest moments of her life. So,
And with me, it was like a father like son moment because my dad, when he lived in Florida, there was a park and he was a kid. He was, I think, like my sister's age, like 10 or 11, I think, roughly.
Okay,
And-
which sister?
What?
Which sister?
And
Okay.
well, I guess North 10, not important to the story. Okay. And he was like messing around in the park and they just put like dirt down, but it rained because it's Florida. So it turned to like mud.
Yep.
And like he literally just sunk down in it like me, but he didn't get out. Like he had to have emergency services,
Oh.
police department, the fire
Wow.
department.
He
and,
was for
like,
real
they're-
stuff.
Yeah, they were like, Daniel, I wouldn't get him out and
Wow.
this is where it gets funny. It's like-
It's not already funny because I'm laughing.
it's funny, but
Oh my
my
goodness.
grandma came driving by, his mom,
Mm-hmm.
and he was like, hi, mom.
Oh, no.
And the police officer walked over and he's like, are you,
Is this yours? Yeah.
yeah, are you his mother? And she's like, yeah,
Mhm.
like,
I'm so
"Yeah."
proud. Yeah. Mhm.
Yeah, and he's like, and apparently the police officer was just like laughing. He's like, yeah, he's just being a boy and he got stuck. And like,
Yeah. We've all done it.
it was funny. So my dad was like, hey, you didn't have to get like extracted. I'm like, hey, maybe by my son.
So the place where we went into Nova Scotia, we visited my grandfather's hometown.
Mhm.
And so he was from Nova Scotia, from this little town called Wolfville, which has a university there, and that's about it. But now it's grown so much that it's like a college town. Where in the past, it was just a tiny little town. But right where there's a bay that comes in, and right about where Wolfville is, not too far from there, is the place that has the highest, lowest tide switch fastest in the world. And it's one of those, it's 6 hours. So you're sitting there and in 6 hours, the water goes to full high tide. And then within 6 hours, it goes right back out. And it goes, I'm talking out like you were looking at the bottom of the ground. But when I was a kid, it was fun because we'd go to a place nearby called Evangeline Beach, and we'd go there. And if you go at low tide, you can walk on the mud. It goes up to your knees. You can step in it as you walk, but it's like, me to get him for you. Ready. He's just trying to, yeah, he misses his mommy and daddy left him today. But anyway, the mud it's like really smooth, silty mud, and it would squeeze through your toes. And you just walk like this, like up to your knees in mud. And then you rinse off. And a few hours later, you can watch the tide come in and the water get like this. It's crazy. It's really neat to watch. There's videos of it that are like time lapse. You can see it real fast. So I did post something in the forum while I was gone. It took the picture a bit. Caitlin noted that the picture didn't load because my wireless was spotty, but I went back and loaded it. I might show it to you guys today because there's something super fascinating about one of the places we stayed. So we're doing surface water today. And if Freddie bothers you, let me know. Freddie's a sweet boy, but boy, is he crazy. Oh, that should say lab rats. That's wrong. Yeah. All right. So surface water movement. Have I got the right one to do, right? I didn't open theirs. Let's see, make sure because I'm having a day. That's yours. Okay. Sorry, Liam. So yes, we're doing some surface water movement. And y'all did pretty well keeping up. Be sure that you look at your grade book though, and make sure that you're not missing anything. Because some of you were like missing some class participation and whatnot. How do you get the class participation for the lessons 7, 8, 9? I mean 7, 8,
Watching videos.
Watch the video. Yeah, watch the video, do your homework, watch the video, just comment. Huh?
And having your mom actually comment on something that will save the comment.
Ah, that works too. You can always just text me and say, I did this. Milo, I think you sent me, did you send me an extra credit? I think you did, and I didn't put it on your test yet. I'm gonna look today if I don't lose my mind, but if you don't see it and you think you did it, remind me. There was a lot of shuffling getting in and back. So I'll tell you my embarrassing tale. This was so embarrassing. I didn't even plan to say it, but you learn from things. So we were on our way to the airport Monday, and we were double checking some stuff, and Cole was looking at the passports, and he actually misread the date on Jason's because the way it says like the expiration date and issue date, you can't tell what you're reading really, one on top of the other. And he's like, Dad, your passport's expired. And Jason's like, it is not. So then he hands me the whole stack. And I look at them all 5 of ours, Mom and the 4 of us, and mine's expired. And I swear I had looked at it. I know I had looked at it when Jason said, go check all the passports. I just booked flights to Canada. This was 3 or 4 months ago. And I went to the safe downstairs and I was like, oh, there it is. But I totally did not read the date as 2022. It said 2021, it expired in April. I was like, oh, I still got a couple more months. I don't know if it was pain meds or lupus or what, but I had I know I looked at it at least once, and I think more than once. And Jason even looked at it because he was needing to enter the information for our flight. So like we looked at it. So at that point we're panicking. So if you ever need Freddie, no, look at his face. So if you ever need a passport, like in less than 24 hours, it can be done, but you have to go to a passport agency and get an appointment. So I know there's one in Atlanta. So I'm thinking, okay, I'll just do this. Atlanta's booked for 2 weeks. So we called New Orleans. We called Atlanta, New Orleans. Is it Miami? Somewhere in Florida. There's another one in somewhere up in, Detroit. I ended up getting an appointment in Buffalo, New York, for Thursday morning at 10:30. Meanwhile, my family is flying out. They're gone to Nova Scotia. So I actually did lab 7 from here when I was supposed to be doing it from Nova Scotia. I was like going back and forth. I talked to Drew some beforehand and after to get his stuff. It was ridiculous. I was like, this is so stupid. So I flew out Wednesday, went to Detroit. Now get this, my appointment's 10:45. I walk in at 9. I walked in at 9 o'clock when they opened, and it was the most efficient government office in the planet because apparently That's weird. Government offices aren't usually.
No, they're-
Like the DMV, you'll be there for years, right? I was in and out in 45 minutes, which
No.
was 45 minutes ahead of my actual appointment time. I was gone by 9:45. Then I have 5 hours to walk around Buffalo with my suitcase and my backpack, which I did. I wandered the whole city of Buffalo. I can tell you all about the architecture because I read every little sign.
Right.
And then I came back, they're supposed to pick up at 3. And I told the guy, I was like, is there any way we can do it earlier? Because I have a flight out of Toronto, Canada at 6:45. Can we get earlier than 3? So he got me a 2 o'clock pickup. I had a black car service that Jason organized because it was cheaper than renting a car or taxi or anything else. So this man came and picked me up and drove me across the border into Canada to Toronto, where I ran in and got through customs and flew from Toronto to Halifax and met my family Thursday night. So moral of the story, have 9 people check your passport and call every passport office. And as soon as an appointment is available, take it, because I had a Detroit appointment and I said to somebody, can we do Detroit? And the person on the phone was like, it's gone. Like they go like this. So
And
Anyway.
the government office seems like a myth.
right.
The
yeah.
DMV experience
Well,
was scarring.
And I looked at their Yelp stuff because I'm like, this is gonna be terrible, right? They have 5-star reviews on Yelp. And
That's impossible.
I'm like, this craziness. Okay. So let's do actual school. Surface water movement. All right, what are we talking about? Well, you know this one. Oh, there goes Rico. Rico was supposed to cycle in and he cycled out. So this is something you should know. And you guys know it. You know the water cycle, but just in case you don't, there's a very short little water cycle. Just in case you have missed this your whole life. Why is this not? Go. There it is. My mouse is dragging a bit. Maybe it's better if I use my screen. I don't know. No, we have no sound. I'm giving up for today. Oh, yeah, today is just ridiculous. I don't even know what controls the sound in this house anymore. It's messed with everything, man. So, no, set by TV. Hold on.
Turn the TV off.
It's set by TV. I'm telling you guys, it's been the craziest month of my life. See, oh, there it is. Maybe I just need the volume up, but I don't know which of these do it.
Falling is
Rain
rain
it out.
down from clouds to the earth's surface. Running in rivers, cooling in ponds, flowing from faucets,
Eric,
irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle, so simple even small children understand the basics.
we hope.
Yet so complex, the most advanced earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time. And yet we don't really understand it.
How to summarize what is known about the water cycle? With 2 words, flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere,
There's always a little bit of water in the atmosphere. We talk about relative humidity. It's a humid day, it's a dry day. Either way, there's water, or sometimes a little, sometimes a lot.
there's a lot of water in the ocean. 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. In the snowpacks atop mountains like the Sierra Nevada. In the Great Lakes. In rivers and streams. In reservoirs and watersheds.
Come on.
In wetlands. In the soil. In and on plants and trees rooted in the soil. And beneath the soil. In water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving. And there is a name for every kind of movement in the water cycle, starting with precipitation.
Precipitation is the process of water falling onto the surface of the Earth. You can have precipitation in many forms: rain, snow, hail.
Rain is falling water in liquid form. Snow, ice, hail, and sleet are falling water in solid or frozen form. Fog and mist, falling water in gas or vapor form. Precipitation that falls directly onto the oceans becomes part of surface ocean and can be churned by wave and wind action into ocean currents. Rain and snow that falls directly on rivers and streams becomes one part of stream flow. Rain that falls onto land takes a different path to the river, as does the snow and ice that falls and collects on mountaintops when temperatures warm.
When snow melts, some of it runs through the snowpack and goes into small streams, tributaries that feed into large rivers.
What about that precipitation that falls on and over land? Some is intercepted by vegetation, plants and trees.
Like you might imagine someone. Maybe a football intersection. These are raindrops trying to get
Charger.
down and the leaves on the tree intersect them before they hit the ground.
And the precipitation that does hit the ground, it can run off. The ground is hardscape, covered with asphalt or concrete, or if the soil is too wet or saturated to absorb more water, like an over-soaked sponge. Otherwise, precipitation infiltrates the soil surface, percolates into the ground.
Think of it as the water percolating through your coffee grounds in the morning. Gravity continues to pull it downward, so it will move through.
Through the topsoil, spaces between soil and rock particles, down to bedrock and further into the fracture, into deep underground aquifers. Even groundwater here is moving sideways or laterally, discharging toward the river, lake, or the sea. Generally, the deeper the flow, the slower the flow.
Some of that fractured water might take a very big, long time, thousands to millions of years to get out.
And how does water get back out into the atmosphere? It evaporates. It's turned from a liquid into a gas or vapor by the heat of the sun.
If you put a bit of water into a bowl and you set it outside on a sunny day, it's going to disappear. It's still water, it's just in the form of a gas rather than the form of liquid.
Water evaporates from every wet surface, even from wet air. Some rain and snow evaporates into the air while falling. Water evaporates through our respiration and perspiration, and from plants through transpiration. Trans means through or across. Plant roots draw groundwater.
And plants pull that water up through their stems into the leaves and then release it back out through evapotranspiration.
Evapotranspiration, a spelling bee worthy term for evaporation from soil and water surfaces, plus transpiration from plants. Evaporated water molecules are tiny enough to flow into the air. Mix the smoke and dirt particles in the atmosphere, cool, condense into visible masses of water vapor, clouds. Winds move clouds into colder air, water droplets collide and merge, grow bigger and heavier until they are so heavy they fall again. Rain or snow, sleet or hail. Precipitation, collection, runoff, intersection, infiltration, percolation, discharge, transpiration, evaporation, condensation. The water cycle.
I like it because it's short, but it's detailed. It covers like all the different pieces or almost all of the different pieces. So she mentioned runoff. So she mentioned hardscape too. So runoff is often when we're dealing with hardscape, which would be if you have a landscaper in your yard, they talk about hardscape. They're talking about anything they do with rocks or whatever, usually rocks. But the street is hardscape, the driveway is hardscape. All these paved surfaces are hardscape, plus natural rock surfaces. And then sometimes soil can act like hardscape. If it's really dry, really compacted, you might notice like if there's a trail in the woods, like my little path that goes down, but if there's one that's really well worn, you might notice that the rain kind of runs over it instead of soaking in because it's so packed. And that's because it's the soil composition that affects water holding. And we have different size of grains here. We have large grain, kind of medium, and then kind of small. So you can think of this as like rocks, maybe gravel and sand. So what kind of grain for your soil, if this is your grain, what kind of grain for your soil is going to hold more water than soil with smaller mixed size grains. Metal? Large, okay, good. So the large grain is obviously gonna hold more water because you can see there's space for it here. There's lots of room for the water to go in. And that's gonna assume that it's soil that's like the actual ground. Now, if you have a pile of soil like that, it's gonna run right through it, right? And keep going. Like if you have a pile of rocks, it would rain on the pile of rocks and then it would go out from underneath. So this is assuming it goes down, down, down to the bedrock. So obviously, when you have soil that's like this soil, that is super compact like that, it makes it really difficult for the rain to get in. And so it can be because of the size of the grains, but it could also be because of how compacted it is. Have you ever watched them, when if you have a landscaper and they're doing some work, you may have seen it with your neighbor or whatever, but they bring those big flat square and they hold it, it's like a jackhammer, but it goes bang, 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 and it flattens the soil. It compacts the soil to some degree so that it doesn't shift, because if it's compacted well like that, it's going to look more like the small grain and behave like that. So you'll get more water running off of it than soaking in and shifting it around.
We've used a manual version of that to compact together gravel so that
Oh, cool.
it's easier to walk on.
How'd you do it?
Just,
Just up and
uh,
down.
Picked it up, and snagged it down.
I don't know,
How tired were you?
and not that.
I'd be tired if I had to do that. Okay, so runoff here, we've got the flow of water down slope. It's obviously going to go down. It's not just going to run off if it has nowhere to go, right? If it has nowhere to go, if we've got a very flat place, it's eventually going to sink in. But if there's any kind of a gradient that allows it to flow, I love this dude. It's just a little rain. It's just a little.
I can't
So-
believe we sent humans to these conditions. It's
Yeah, right.
weird.
So since we've been gone, we've had major hurricanes, right? And that was where we went actually, Ian. So Ian like whipped up in Florida, right? And then it went out into the Atlantic and then it came back up and it hit the top of Nova Scotia. So it hit exactly where we were going. So Jason had to keep checking in with our Airbnbs. Do you have power yet? Because we were thinking we weren't gonna have anywhere to stay because some of these places are pretty remote. And they're like, it's like one road that goes down and back. It's in the middle of nowhere. But we saw so many down trees, just entire roads where trees were knocked down everywhere. But you could see them all leaning one way. If they weren't knocked down, they were leaning and all leaning the same direction. So you could tell where the wind came through. So your rate of precipitation affects your water holding capacity. So if you have just a little rain like this guy, as opposed to what a real little amount of rain would look, soil that gets rain sprinkled on it, like a watering can, is less likely to run off than if you throw a fire hose on it, right? It has time to soak in. So soil which is what or too dry? James. Compacted? Anybody else got another one? Bailey? Not compacted? What do you think, Alex?
Too moist,
Moist?
too moist.
Jack? Everybody's going. I love it. Smaller. Yeah, we got lots of them. Okay, so we're looking for saturated. It's a big word. It's a big word. Okay, so yes, kind of. Spelling bee. Yeah. Yep, there you go. So soil which is saturated or too dry will absorb water at a slower rate. So if you've got soil that's already been rained on and rained on, like when you see floods and stuff on the news areas, especially like Midwest, or sometimes it happens like along the Mississippi. I don't know why that's that area, but you get a lot of rain and a lot of rain for a couple days and it gets to the point where it can't absorb anymore. And that's when it starts flooding everywhere. Mhm.
Or like too dry, like Dubai and stuff. Like
That's the other
they
thing.
Get like a little bit of rain.
Yep.
they, like, flood.
Yeah, so yeah, even here in the US, so if you've got a place that gets too much rain and the soil is just soaked, it can't take anymore, you get a flood. And then also, or it runs off, in this case, it can run off. And if it's level, you get a flood. And then also, like you're saying, so if you live in a desert, they get monsoons, which are like giant rainstorms that appear. And they're not a place that gets, nice random trickles of rain like we do. They get this big rain all of a sudden, and they have all these little, you can see these little creeks and stream beds everywhere out there that just only work 3 or 4 days out of the year, but it's essential that they have them. People will build them. My friend has a bridge to get to her house because there's a little, she's in New Mexico. There's a little rock red bed creek that goes through there because she needs it a couple times a year and that's it, but it's important to have it. So slow and gentle precipitation absorbs the fastest. So think of this like your nice little gentle watering can versus your fire hose. You're going to want your watering can if you're trying to keep your soil nice and moist and not too crazy. So runoff again, we're still talking about runoff, downslope. So vegetation affects water holding capacity. This is branches and leaves are gonna slow precipitation like they were showing in the video. Rain comes down, it hits all those leaves on the way down. It doesn't come down quite as hard, right? And roots are gonna maintain pore space. Okay, pore space is important to think about when we were talking about grain size. The areas in between the grains, that's your pore space. And you want the pore space to be big enough to absorb. Like, remember, we think back to those 3 different grain size. If you have large grain and then you have a lot of pore space, that can hold more water. But roots will actually form pore space, and that will allow for more absorption and less runoff. So this is another reason why it's good to plant any kind of vegetation if you're trying to prevent erosion. You'll notice that when they do the like highways and they have a median or anything, have you ever seen that stuff they spray on it? You know what that is? You seen them spray it? It's usually green, bright green.
Yeah.
Know what it is? Yeah, it's like, it almost looks like spitballs, right? It's like paper that's been ground up is what it looks like. It seriously looks like spitballs, but it's green and it's full of grass seed and fertilizer.
Yeah.
Yeah. Mhm.
Like, not even just like medias and stuff, like when we went up to South Carolina, we my mom, like
Yeah.
it was like everywhere, because I think the store just like there was some.
Yeah, yeah.
It's, like,
Mhm.
everywhere.
So they spray that out, not because they're trying to make the grass pretty, they're not. They just spray that out because they're just trying to get something to grow real fast, and that grows really fast. Now, my neighbor, y'all may have been here at the right times of year, but he has his path and then he has that whole area down there and he keeps working, right? Tearing out every tree. So he puts down ryegrass, which is super bright green, looks like pictures of Ireland, you'd think it's like, whoo. But it does. When we went to move in, that's the first thing we saw, and we're like, oh, that's so gorgeous. But it's only for like 2 weeks out of the year that it's that color. But he throws it down because it's cheap, it grows fast, and it puts roots in the ground and it holds everything in place. It allows for more water absorption and less runoff. Oh, Liam got kicked out and Liam's back in. So another thing that affects runoff is going to be slope. So what kind of slopes are going to erode fastest? Okay, Piper. Yeah. Anybody else want to try another word for it or anything? You want to try, Bailey? Yes, steeper slopes. All right, so yeah, this is what we're getting at. Yep, steeper, bigger, quick, many times.
Larger.
Yes, there we go. Larger. Yeah, so yes. So if you look here, you've got runoff coming from the mountains, going through a plain, and coming from this little pond where it's collected. Thing about this little pond is it's being fed from underneath. Do you see? So it's being fed from underneath a spring, is basically what it is. Have you ever been up in the mountains and seen water coming right out of the cracks of the rocks on the side of the road? It will do that. Because there's aquifer space, the water absorbs in there and it just sits there. And sometimes they've cut the rocks to make the road be able to go by. And the water will just kind of ooze and trickle out of the rocks. And that water is usually really purified and really cool. When I was a kid, my dad used to stop and get like a styrofoam cup out of the car and get me a sip of it.
Yeah.
Like I didn't die of amoebas or something, but you know, he was just trying to, mountain water, it's fresh. So,
We went to Indian Springs where like
Uh-huh.
their spring water is like sulfur,
Mhm.
like, a lot of sulfur. It's supposed to
Yeah.
have like healing properties.
yeah.
And like we tried that. It's pretty cool.
Ooh, yeah, uh-huh. It's a really great way to see that. The water kind of oozing out of the rocks and seeping out is if you go up when it's below freezing, you'll actually see it because you'll see it as ice and it catches the light or it'll refract the light. So you'll see these like white little frozen tiny miniature waterfalls. It's really pretty on the sides of the rocks. It's kind of cool to see it that way. So stream systems. So you have networks that collect freshwater runoff from the land and carry it to the ocean. So what do we call these little streams that lead in? These are our what? What are they?
Tributaries.
They're tributaries, right? Okay, and we talked about that before. So that's what we just did there, right? There you go. So you've got this thing right here. This is one that's important to remember. This is a divide, and that's basically wherever you've reached your highest point of altitude in an area, in a watershed. So it's important to remember that a watershed is all of the area with water that drains into one basin, be it a lake, a pond, a river, a stream, whatever it is, it ends up here and it comes all from this area. Somewhere in this area, there's going to be a high point all the way around, right? And it may change. It may, you may have a mountain that goes this way and then that way, but it'll be contained, right? And that's your watershed. And the dividing point of your watershed is going to be wherever your highest peak is, like that. And that's your divide. And this can be a small area or it can be acres and acres and miles and half a state. I mean, it can be massive, but somewhere there's a divide. So what are these? What are these called? All the land that drains into a stream system?
Tributaries.
Not tributaries. Somebody back there, come on, Parker. Was it? Not quite. Well, they're close. Somebody. Drew, do you know? No? All right, Alex.
Watershed.
Watershed. I just said it, y'all. Watershed. So that's all the land that drains into a stream system or whatever your basin is. It's right there. This one, did you notice the little Rico is here? This is one that's worth remembering. The reason it's worth remembering is because one day as an adult, you will likely buy property and you will be a part of some watershed. What watershed do you suppose we're a part of right here? Oh, yeah. So if I come up here and I put like all kinds of chemicals and fertilizer in my grass, and then I start fertilizing all the way down the hill, what do you think is going to happen with all of that?
I'll wash into them.
It's going to go right into the hooch. So I have to be very aware of that. I have to be careful because we are part of the watershed for the hooch, and the hooch has all kinds of organisms in it. It's got trout and all sorts of things in there. So yeah, you can fish trout out of there. I think if you're under 15, you don't need a license.
Yes.
And y'all are welcome to, by the way. If you ever want to come fish, you're welcome to, but I will tell you this. You have to do two things in order to be successful at it. You have to call the dam number and find out when the release is and make sure that you are not here before the release or, within like an hour or two of the release, because you get drowned. And then so it's best to go like, 5-6 hours after well, probably more like 10 hours after the release. It's probably good to go. And you need waders because the stream flow of the hooch is fast enough. And I've done it myself. If you cast off the shore, you're going to have to reel because it's gone. I mean, it's gone. So you're going to have to reel really quickly, or either that or you have to have a very serious sinker because it flows. So if you've got waders and you're there at, when the level's low, you can walk right out and you can fish. If you're over 15, I think you need a license, but if you're under 15, you can fish right there. All right, so watersheds, important to remember so that you don't ruin one day. So here's your streams again, and networks that collect fresh, remember this, there it is again, networks that collect fresh water runoff from the land and carry it into the ocean. Again, there's the same definition. So we were talking about this. What are the high areas that separate watersheds? Drew, that's the divide. Okay, that's what you want to remember. So you got these divides, they separate watersheds. Yay, if you're on one side, you're not affecting what's on the other side. This is important when you're dealing with farming in particular. Like you want to know where your fertilizer is ending up versus the guy on the other side of the divide. It may be going someplace completely different. So you could be fertilizing your land and the guy on the other side is fertilizing his land and you're having impacts. I mean, he could be a mile from you, but you're impacting two completely different watersheds. So it's important to know that. So that's watersheds. And last, now we're moving on to stream load. I like this part because it gives you good visual pictures. I don't know. So your stream load is all the material that the stream carries. So you've got several different things going on. You can look down here and what's this word again? What's this one?
Siltation.
Saltation. What is saltation? We've talked about it. What's it mean? Jack, do you know? We talked about saltatory movement. We talked about sand moving by saltation if the wind is blowing it.
It's anything being moved by a fluid.
No, not quite. Remember I said kangaroos move by saltatory movement, so do rabbits. What is it?
Bounce.
Jumping, bouncing. Yes, good. That's it. Jumping, saltatory movement, saltation, any of that is bouncing. Remember saltos? Oh, saltos. Okay, jumping. So anything that jumps like that is saltatory movement. Saltation then would be kind of the bouncing along the bottom of the stream bed. So you can envision it, that there are rocks that are too heavy to be like really picked up and carried, but too light to stay put, and they bounce along. So they jump along. So that's saltation. And then traction right here, this one's getting dragged. There are going to be some that get dragged because they're not running into something else. They just kind of drag along the bottom, right? And then you have the bed load. And basically all of this is the bed load. It's everything that's being carried. And then you have this stuff up here, which is the tiny stuff. So, yeah, sorry, I didn't mean to click it. You were going to say it, weren't you? Suspension. So suspension, yes, these are the small particles that are held up by turbulence as they are transported. So we talked about both saltation and suspension when we talked about wind erosion and particles of soil that are being moved or sand that's being moved. What does suspension look like with sand or dirt? James? Like a dust storm, exactly. So it looks like a dust storm, or sandstorm. That's right. So now here's a thought question. Why do we have the same type of movement? Saltation, suspension. Why do we have this same type of movement with particles in water and particles in air? Alex knows
They're
it.
both fluid.
They are both fluids. Air and water are both fluids. So whatever happens in air can usually be translated to what happens in water. And interestingly, here's my little sidebar. I can tell you one thing that was cool about this trip where I thought, oh, I wish my kids were here. So we went to the Alexander Graham Bell Museum in Bedeque, Cape Breton, Nova Scotia. Apparently, this is just where he wanted to hang out and retire and spend his time. It's not where the famous first phone call was made. That was in Boston, right? But but do you know what his main job was, Alexander Graham Bell? What his main job was? Do you know? No, that's what's his name? Oh, I can't remember. Anyway, so he learned from his father and he taught deaf people. He taught deaf people how to speak. And this is fascinating if you want to go down an interesting rabbit hole. So his father invented something called visual speech. And Graham Bell, so his father was Alexander something with an S. I can't remember Bell, and he's Alexander Graham Bell. So Graham Bell came up with a way to kind of perfect the visual speech. But basically the way this concept worked is they would describe to a deaf person, like in writing and with, I guess, signs of a certain type, where soft palate raised, soft palate lowered, lips closed, lips open, vibrate through your nose, don't vibrate through your nose. And every one of those things, parts of speech, had a symbol, like it may look like this, or it may look like that, or it might be a circle, or it might be a line, right? And then what they did is after these profoundly deaf, like not people with a little hearing, profoundly deaf people learned how to position their apparatus to produce a sound. He would put all of the sounds together in one like little conglomerate symbol. And then they would look at that symbol and they could make the sound. They knew exactly what it was. Like they could make the word basically by doing what the symbol said. It's really interesting. So anyway, he spent his time, this is where we're drawing back to this. That's what he did. His wife was also profoundly deaf, by the way. She was his student. And then when she turned 18, they got married, which is today, I think we'd all be like, ooh, but back when he was living, it probably wasn't so weird, but kind of a creeper move these days. So he hung out in Bedeque, and the man experimented on everything, not just the telephone. The telephone, he had it pretty well perfected, but it was kind of like a fluke that it worked when it worked, because remember, acid got poured on some lines and there was enough conductivity to make it work. He also invented something that you could use sunlight to produce sounds. It's pretty cool. So he liked to just play because he had all this money from the phone pad, so he could kind of do whatever he wanted. And he was fascinated with flying. This is like around the Wright brothers times. Like he was fascinated with it. But his big thing was hydrofoils. Do you know what a hydrofoil is? Drew knows. Oh, what's hydrofoil, Drew?
The model of airplane, the kind of model of airplane?
No, what is a hydrofoil in particular? It was a part of what he did. Do you remember what it was? No, do you know?
The multiple wings.
Yeah, that's the wings are the foils. What is it, James?
It's basically a circular
Mm-hmm.
stick
That's a good way to describe it.
and two little wings on it.
Yeah. So you know how wings are curved, right? Because it produces lift, right? You got the same volume of air coming right here, and then some has to go over and some has to go under. This has to go over and it goes over more space, spreads out, it's less dense, whoop, up you go, right? So hydrofoils are the same thing, but for water. So he had this massive, massive thing called the Silver Dart. It was wooden and it was huge, and it was shaped like a big torpedo. And his thought was, if I drive, and this is where you get fluids together, right? If I drive this hydrofoil super fast through this lake, and we're talking about, it had dozens of these underneath, not just like one. It had these big frames with all of them stacked up underneath. So he would drive this thing through the water and the water would act just like air. So he would get lift from the hydrofoils. And his thought is, if I get just enough lift, I'll just go right up out of the water. And they actually did get a little up, and it, was not as successful as he wanted, but that's because the properties of a fluid are the properties of a fluid. Density is one thing. Water is way more dense than air, obviously. but a fluid's gonna behave like a fluid's gonna behave. So he was able to use a concept for water and apply it to air. So same thing here, same thing here. So the sand and the pebbles that the stream rolls and pushes along. So we have this suspended load up here. What do we call this stuff down here? Like it,
Bed load.
bed load, yeah. So all the stuff that has the siltation, the traction, that's your bed load, right? All right, so what are these things? These are dissolved minerals that are transported. What do we think, Jack?
Solution.
Ooh, bingo, nice job, nice job. So yes, they are in solution. There are lots of minerals in solution in the water. There are, like, if you go to the lazy river at the water park in Cumming, there's all kinds of stuff, chlorine and stuff that's in there, and probably whatever's in urine, I'm sure it's in there too. So you got lots of stuff that is suspended in there, and it's in solution, and that just floats along. So you have something called carrying capacity with the stream. You've also got carrying capacity when it comes to ecology. Do you remember what it means in ecology? Do you know, James, do you know? Yeah, the amount of just, living organisms in general that can populate a certain area, that can live in whatever the population of pine trees is, whatever the population of gnats, whatever. Every ecosystem is going to have like a max amount that it can feed, house, whatever. Carrying capacity of stream is a little different. So we have our discharge, all right, and that's what how we term like how much water is moving through the stream. So something like the river, that's crazy and difficult to calculate because they're always dumping water into it, right? But if it's a stream, a regular stream that flows, especially if it's spring fed, you get a fairly regular amount. And the way they do it is there's a formula right here. They take the average width, the average depth, the average velocity, and they come up with a discharge here. So that is the measure of volume of stream water that flows past a given point in a given time frame, and it's what? Bailey? Yeah, it's so hard. It's right on the screen. You got it. So there you go. So this is important to know, because if you don't know what the normal discharge is for a stream, how do you know if you're having low discharge issues, or you might flood? So that's where you start talking about that sort of measurement being important, because if you're going to build a house somewhere, you're going to want to know how much can the stream hold and what's its average. For example, the river probably has some averages. It certainly has a high average and a low average, but could it flood? Well, how high could that river come up? I mean, could it come all the way up to the house? What would it take for it to come all the way up to the house? That's a slope. Yeah, a lot. So floods are when you have water that spill over whatever the typical banks are and onto the land. So we've got this will give you here. So what is it that extends from the stream bank? It's broad and it's flat and it's covered by excess water during a flood. Check.
Floodplain.
Floodplain. Okay, so your floodplain, do you know where one is? Right, there's one really near here. There's a little bit of one there. The big one that's near here that you can go see, and you don't usually get to see it in action, but on McGinnis Ferry, right on this side of the bridge at McGinnis that crosses over the Hooch, there's just this with the soccer fields there, and then the soccer fields stop, and there's this big green area, right? That's a floodplain. That's why nobody's building there, because that's where the Hooch will overflow. Now, interestingly, it's very green, it's very lush. It can be very muddy, obviously, because it's going to take in excess water from the river. You can't build on them. You'd be really stupid to do that. And if you go at dusk or dawn, it is flooded with deer, not water, deer, because it's so nice and lush. They're out there eating everything. So this is your floodplain right here. These people have done whatever calculations are possible and determined that this whole area is probably not a good place to live. This guy is a little brave. I mean, I guess it would depend on how likely it is. Now, when you buy a house, this is part of your insurance calculation. Yep. They will look and see what water sources are near you, the likelihood that they'll flood, floodplain, all that good stuff. And so it's important that you keep that in mind, because when you go to buy something, that's what's gonna matter. So, yeah. Look at you. So yeah.
We're back. Okay.
So flood fringe, this is basically saying this is really rare. It's probably never going to happen. So this guy probably built here because it's a beautiful lot, and he can see the little river and it's probably never gonna happen. And his insurance company probably said, okay, but your rate's gonna be a little higher.
He's like
Right.
stupid mother nature.
Yeah, very brave. So if you look here, these are flood stages, okay? So this shows you basically where it's occurring. So flood stages upstream are a little smaller, downstream they're larger because it's catching more and more water as it goes down. So this right here is actually this is for the Mississippi, I think. And you can see it's very specific. I mean, 9 a.m. They've got different days, but they're telling you where right here is where it hit its high. So 9 a.m. Wednesday, March 4th. Right after that, it hit a high. So there's probably some event there that caused that rain or whatever. So how do we monitor for floods? Lots of ways. We have these kind of instruments that sense everything, whatever. We have actual sites where they take real measurements and look at it, and people actually don't let everything be automated, which is probably smart. And then obviously all kinds of telemetry that send information from one place to another and do all kinds of calculations all the time. And monitoring, this is the kind of stuff that where if you're watching the news, this is where they're getting their information from, is all the data is coming from stuff like this. And then these guys over here, any of the centralized reporting. So this would be like NOAA, US Weather Service, US Geological Service, that kind of stuff. That's what we're talking about here. Groups that are together. Now NOAA, you guys know what NOAA is, an OAA. It's the North something Atlantic. Oh, why can't I remember what it stands for all of a sudden? My brain just died. On my phone. Oh, right here. NOAA does all of the like Atlantic Ocean, North Atlantic, I think it's North Atlantic something. NOAA has the Santa tracker every year. That's kind of fun. There it is, National Oceanic and Atmospheric Association. That's it.
I know that.
But NOAA, if you're traveling in the north, like if you're going to Alaska, or like in our case, when we were in Cape Breton, you can put in NOAA Aurora, and it will actually give you a 30-minute forecast for where the Aurora Borealis, where the Northern Lights will be shown, wherever you are. And it's really cool because it cycles. I don't know if you can see my phone screen, but it'll show where you're anticipated to see them and at what time. So if you want to go see the Northern Lights, you can go, when we were there in Nova Scotia, there was like a 30% chance that if we drove an hour to one place, we might see them. And we were like, but it's got this whole, like, it circles around. Ooh, here's where you see it. And it's a 30-minute forecast. So it's pretty darn cool. So NOAA is one of these organizations that puts all this information together, which is cool. And they will give you information like, what's your risk level? And this right here, now I grabbed this because it was just funny to me when I was searching on this kind of stuff. This is actually from the city of Virginia Beach. And this is their defense against coastal and sea level change. So if we're going to flood, what's our defense system? So they talk about, here's where future sea level is, relocation, look, acquisition. We're going to take this house, we're going to pick it up and we're going to move it. Okay.
Buildings, I saw so many.
Yeah. Anybody ever seen, like, bless you, like they do this a lot on the Outer Banks and stuff. They build their houses up like this. There's a part of Virginia Beach called Sandbridge where there's a lot, it is a sand bridge. And that's what happens here. Elevated roadways, that's smart, right? Living shorelines, maritime forests. So this is obviously a way to try and keep some erosion from happening, to keep the dunes built up. And the dunes are right here. And they've got oyster reefs and stuff. But these dunes, like I was saying before, dunes are super important at keeping ocean water and wind where it should be. What'd you say, Jack?
Like that like island was, like the whole west side of it is like the flat stuff, so everything's like on stilts.
Yeah.
Because like when a hurricane came through, like
Yep.
cut it in half. And then like the whole east side is a bunch of trees and berms and stuff, and a lot of houses are like on ground.
Yeah, if you want to pay really, really expensive homeowners insurance, go buy one of those houses on sticks. I'm not kidding. Really expensive homeowners insurance. But what a view for the days that you're not being knocked over by a hurricane, Well, how often does a Cat 5 really hit here? That's a beautiful view. That's a toss up. So how do streams develop? We know how streams develop. We've talked about this before. So you've got your supply of water, and that's coming from either precipitation or from underground. So what do we call the beginning of stream accumulation? What's the word, Alex?
Headwater?
Okay, here we go, headwaters. So headwaters can be from the top of a mountain where it's coming down, like right here in this image. It can also be coming from a spring, like we were saying. So You can see, bless you, you can see headwaters lots of different ways. Now, sometimes the spring is a little tiny and you don't notice it, and sometimes it just sort of comes out of nowhere, like it flows out of a rock. There's one, oh, I'll have to find it for you guys. There's one like it's a spring and some streams. It's in a mountain. I can't remember where it is. Maybe somebody's seen it before. But there's a natural gas leak underground. I think I'll be finding it for you guys anyway when we get to that topic. But there's a flame behind the waterfall and it doesn't ever go out because the natural gas is feeding it constantly at a constant rate. So this flame just burns behind a waterfall all day. It's really neat. So we have stream development. So what gets carved into rock or sediment by a flowing stream? Do we know what that's called that gets carved into the rock or the sediment? Milo. That's close. Stream channel. We're going to go stream channel. So you get a little channel, carves it out. And obviously the more water that's flowing, the wider it carves, right? And what are the edges that hold the water within them? What do we call those? It's easier than you think. Right.
Riverbanks.
There you go. Yeah. Riverbanks, stream banks, banks in general. Yeah. So the banks are the edges.
With money.
There you go. So the banks are the edges, and then the stream, like you can see the channel here. So it says deep and narrow right here, whereas this one is shallow and wide. And they have maximum flow velocity is going to be right in the middle there, because on the edges, it's going to be a little slower. This is why I talked about the dam before and why you don't swim in the hooch out here without like paying attention to the dam stuff and life jacket. Because think about it this way. When the dam, you've seen the dam, right? Everybody has seen Beaufort Dam, right? Okay, so it's up, there's a bridge. It's like a land bridge and the dam's built into it and there's goats eating the grass. It's really kind of cool. If you haven't been, it's worth driving it. It's right over here. Where is the water from the dam coming from when they open it? Where is the water coming from?
Up the hooch.
Well, Hooch is way on the other side, but it's coming out of what? It's coming out of Lake Lanier. Is it coming out of the bottom of Lake Lanier or the top of Lake Lanier? The bottom of Lake Lanier. So this water out here is sometimes at most 5-6 feet deep. A lot of it in places is a foot deep. So what do you think the temperature differential is between the water out there and the water here?
30.
Yeah, I mean, we don't know the exact degrees, but this water is going to be warmer, right? Than the water coming from the dam. So the water coming from the dam is coming with a ton of force, right? Because there's a whole lake behind it pushing on it, right? And if you've got warm fluid and cool fluid, how do they relate?
Warm on top.
The warm goes to the top and the cool fluid sinks to the bottom because when it's warm, it's less dense, right? So the cold water coming out of the dam goes to the bottom of the river and pushes way faster than anything you can see on top. That's why people die in this river, because they don't take that into consideration. It's an undertow that you cannot see because that water's colder. And there are currents like that in the ocean. There are currents like that in rivers. There's currents like that everywhere. But this one is really pronounced, especially right here, because of that. So people will climb. If anybody ever invites you to go jump off Settles Bridge, which is apparently like a teen rite of passage in this area, don't do it. It's really stupid. And if you do it, put on a life vest. Because a couple years ago, a kid jumped off and never came up. And it happens relatively normally here because of the way people are stupid, jump in and get hurt or die. This water's so cold underneath. So stream development. So this is what happens as streams push ahead. Do you know what this little situation is called? You've got rock here, water pours off, and the stream is undercutting right in here. So what do we call this process? Do we know, Bailey? What is it? It does make a waterfall. Do we know what we call this whole process that calls it to cut back into here? Okay, so this is what we call headward erosion. So think of it this way. You got your water and it's already eroded all the soil on top, right? So now that the soil's all gone, it's on this rock, and this is the most water resistant thing it's come in contact with. Now, obviously it's going to erode that rock, but nowhere near as quickly. So it's going to reach a place somewhere where that rock surface runs out and it needs something softer. I mean, it will find something softer because it'll erode whatever this is. Whatever was here was softer than this, right? So it gets eroded, cuts down and makes a lovely waterfall. But as it's doing so, the ground underneath is getting cut into until eventually this will collapse or whatever. Whoops, it'll collapse or it will eventually erode because the water is whipping over it so quickly. So as a stream forms, you get what's called headward erosion, which means as the stream goes this way, it's actually eroding backwards. So if your waterfall is here a million years ago, it might be here now. Like it could be way out there and a million years later, it's a little more this way because it's getting pushed back over time as it erodes. Does that make sense? You could do it in your backyard with a hose on the ground if you wanted to watch. It might happen much faster. So we have stream capture. And this is when one stream joins another stream and they become like sort of one unit. There's another word for stream capture. Do we know what it is? This is a great one. Do you know?
Stream piracy.
Yes, stream piracy. What a great term is stream piracy. I mean, think about it for real. Like that's a great term because it's just when you think about it, you say, what do we have? Like video pirate, what do they call it? When you steal people's music. Yeah, cyber piracy, all that kind of stuff, right? You get piracy. So this is stream piracy. And basically this stream stole this other stream and now they're happy. So stream piracy. Actually, I saw some examples of that on my trip. So this is what happens. This is how you form valleys. So where you have a stream that enters another stream or a body of water, it does so at the lowest level. It's trying to get to sea level because gravity is pulling it down. So you have a little channel that's cut here and the sides get weathered over time. You get mass movement where all that stuff gets shoved away and then you get this valley. So does anybody know what we want here? This is your base level, and that's this level right here. This is the lowest it can get right here all along. And this is obviously going to pile up some sediment and that may change some things, but your base level is where it's trying to get to. And we've done this. What are these? Yep. What's this one? These develop as meanders, develop straighter paths. Piper?
Oxbow?
Oxbow lakes. I love Oxbow lakes. They're just so cool. Remember we watched that video? It was like a time lapse where you could see one little lake join another. You remember that one? Do you remember, guys? It was really cool. You could see one little river join another little stream, whoop, cuts off and you get an Oxbow lake. They're a great example of where meanders used to be. So deposition of sediment. Where does it all go? Okay, so you have sloping depositional features formed at the base of slopes, mostly sand and gravel, common in dry regions. So what do you call this? We're looking at these, everything comes down the hill. What's it called? Do we know? Do we know? Got all the sediment down at the bottom of the hill, rocks, gravel. It makes a shape. What you got, Alex?
Is it a dune?
Not a dune. Look at the picture. Where's all the sediment gone? Bailey? At the beach. So what we're talking about here is an alluvial fan. Okay. The stuff is alluvium. That's what they call it. The stuff that gets collected. But if you look here, as all this stuff gets eroded down the mountain, it forms this fan, right? Where have we seen something similar to that? Where you have the same triangular deposit, but it's going to develop where a stream meets a body of water. What's that called? A stream meets a body of water, it forms a big triangular. It's the same process, different name. Oh, come on, there's a Greek letter that goes with it. Hey, James, delta, yes, okay. So if it's water, it's a delta. If it's solid stuff, it's an alluvial fan. So here is your alluvial fan right there. And your delta, they're showing you these little tiny ones that are on here. Ding, 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 ding. Obviously, they're bigger ones. When we were up in the mountains going through Cape Breton is interesting. They've carved a road into, it's called the Cabot Trail. They've carved a road essentially right into the side of the mountain. So you literally have giant mountain on one side of your car and ocean on the other. Like there's not a nice slope. Oh, look, there's ocean over there. It's not gradual at all. It's very abrupt. But I saw a lot of these alluvial fans. In particular, there was one area we went to, they were mining in that area. And they were actually, the way they were doing it is they were weird. They were mining the top of a mountain. So it was like they were digging a cavity down into the mountain top. But below it was a road and like a lake and everything. So what they did is they just shoved it over the edge down to the bottom where there were some machines and like a big barge. So there was a huge alluvial fan of everything they were mining that just came tumbling down the hill because they just shoved it over. But you could see it. I mean, it was clear as day. It started at the top and it came all the way down and it spread out. It was a man-made alluvial fan, but that's what it was. And you know, you just saw Rico there. So alluvial fans and deltas, keep them in your head. Same process, different name. So we have what happens here when you've had a flood and then it dries up and you lose your little stream. So when your stream is gonna actively start behaving again and it starts cutting, we call it what? I get it. We call it rejuvenation. It's awake, it's rejuvenated. You see you can break this one down. RE means what?
Back again.
Again, yeah, repeating again. What's this right here? Juve, where have you seen that?
Young.
Young, okay, young, again. Oh, what do you know? It's behaving like a young stream again. It's exactly what that means. So lakes, freshwater, and wetlands. Jack knows all about wetlands. All right, we have 3 types of wetlands mainly. So any freshwater wetlands is any land that's covered with water for a part of the year, and they can serve as filtration systems for water, and they're often protected for preservation because they're super duper important, wetlands are. So what do we call the ones that are fed by streams and deltas, Jack?
Marsh.
That's marsh. All right. So what do we call the ones that are near streams but are full of vegetation? Lily? Swamps. And Chloe, you can get this one. What do you call the ones that receive water from precipitation? That's a bog. All right. Do you know what a peat bog is? Oh, yeah. What's a peat bog?
Wait, what?
What do you know about peat bogs? Anything? She's- Okay,
It's
yeah,
got dead bodies in it from millions of years ago.
it did. So yes, peat moss can fill up peat bogs. They actually use peat for all kinds of things. They use peat for planting things. They use peat in whiskey production, especially like in Ireland and Scotland where there are a lot of peat bogs. They use it for that. They go in and they cut it in squares. This can be used for fuel. It's like this big, it reminds me of kinetic sand. It behaves kind of like that. People go out there with like big shovels and cut chunks of it out like giant cubes, right? But Alex is right. It has a strange preservative property, and they have found bodies in it that have been there for hundreds of years. And they pull them out and they're like a mummy body. It's wild. Really, really wild.
I just meant that it's partially made out of the dead dinosaurs and plants.
That too, it is. Yes, a lot of that's true. Yes, but they have found people bodies.
So not only to have dead bodies, it is to find dead bodies.
Yeah, I think the most famous one was this one in Ireland. I think it's in Ireland, but you can look it up and it's interesting. This man, they found this man, and when they pulled him out, like he was like a mummy, but he had like a little change purse on him and have you seen this, Chloe? Yeah, I think you're right. Yeah, he was. Yeah, it was really interesting. Yeah, that's right. He had a rope around his neck. He'd been like, yeah,
Great.
it's fascinating. It's really, really interesting because it was like a mystery from hundreds of years ago or whatever. And here's this dude, like, and you can tell how old he is just based on the clothing and the coins and stuff too. Like they didn't have to do too much study, scientific study to figure that out. Okay, so here are some of your answers. If you're way in the back, you might need to come up front to see them. But so next week, I'm going to be
Is Freddie gonna be here next week?
giving you, Freddie will be leaving on Sunday. Poor Freddie. What, I say your name, Fred? Fred. What are you doing, Fred? Freddie. He is, I'm seriously, the nicest, and he does, this is my favorite. Like he uses his little paws like hands, like he'll talk to you, and my gosh, he's so good. And Ozzy didn't get along with him last time, so I'm happy they're friends now, because Ozzy was mean to him. So they do go, boy, Freddie. He's 3, by the way, so he's like a year older than us. He's a good boy. He's their second Westie. They had one named Maggie for a long time.
My dad had a dog named Maggie.
Yeah, and when Maggie passed, they got Freddie. Hi, Freddie. And what's his brother's name? Do you remember? He has a brother that lives with their neighbors, and that's kind of funny. I can't remember his name at the moment. Shoot. But anyway, he's a sap and he loves attention. So next week we'll have lab and everything like normal. And we are about to wrap up Unit 4. So, well, actually, no, we're not. You got some time still. But when you get all your Q4 packet, be sure that Q2 packet, be sure that you look through it and everything makes sense. So I'll leave this up. And if you guys want to check, because I know it's kind of hard to see back there. And there's one more page, I think, right here, if you want to check them. And one more thing, I was going to show y'all one more thing before you leave. I don't think anybody was, I'll go back to it if you need to see it. So I put something in the, don't go anywhere yet. I put something in the, in here. And I put it in, where did I put it? I think the only person that commented was Caitlin, but some other people wrote back. I think I put it in here. And I want y'all to talk to me about it before you go. So I put in a picture. Was it in here? Yes, right here. Okay. So this is where I was. And I didn't want to give you too many details, but I want to show you a couple things first. I'm going to start with this picture right here. So I made a little cairn. Isn't that pretty? Now, here's the thing. I'm sitting on a beach somewhere in Nova Scotia. Tell me what you notice about the rocks. What's the first thing you notice?
They're all very colorful.
They're all very colorful, yeah. I actually have some for each of you, and I'm gonna grab them for you in just a minute before you leave.
Smooth, but also pop.
Smooth, but pop. Look at it for just a minute. I'm gonna grab, and I'll be right back. Look at that for just a minute and talk amongst yourselves. Why is that weird? That's weird. Something weird about it.
It's smooth, but not smooth.
There's
There's a benign contribution to the discussion. They all taste good.
Oh, that's a good one.
They all taste like ramen.
I bet that they all probably taste like.
I hit you in the head.
It tastes like pizza. That's right, it tastes like pizza.
No, it will keep tired.
So, what have we decided? What's interesting there?
If you eat it, you'll probably be eating your teeth as well.
Shh. Truth. What do we notice?
They're all kind of patterned and.
It keeps getting smaller.
When you guys went out to the backyard and collected rocks, what kind of rock did you find?
Granite, sedimentary.
Most of you found what kind?
Granite.
There were some sedimentary ones. Most of you found granite because we're sitting on a deposit of. Why are they all different? Here's why.
Because it's had things. moved
Look at the colors.
Upriver.
This is one beach. These were not placed here by people. Look at this shoreline right here. This is the shoreline. You see it? Make it a little bigger. Okay. Actually, look, you can see a little alluvial fan right here where they're falling down. Here they are. I'll get you a close up right here. Okay. You've seen bulldozers cut into the ground. You've seen what that looks like. Does it look like that? What's different there?
There's lots of rocks.
There's lots of rocks.
Maybe like 1.5.
Are the rocks down here big or small?
Small?
Yes.
Ah, good answer, yes. Look at these, look. What would cause rocks of this many different types and this many different sizes to all end up in one place? How'd that happen?
The ocean.
Not the ocean.
The
Well,
ocean.
This
I think alien.
is super cool.
Uh,
This is a glacial deposit. So these are from everywhere. These came from I don't even know where. This is glacial till. So these were all plucked and then they were all placed. And this is what's built on top over the years. But this business down here is all glacial deposit. Look at the sand. See it's how different? So that's really, really cool.
That's why we can't-
So if you come over to the counter, I'm gonna show you a couple things. So I actually ordered, and I'm very excited. I ordered a rock tumbler that is large enough to take large rocks. And then they put it directly behind, they put it on the garage door, right at the garage door, directly behind the tire of the Sorrento. So the whole pulled out, ran over it and bent it like that. I mean, it is destroyed. I have to send it back. Why do you put stuff there in your garage? Clearly your car is gonna come out of the garage. So I got a couple things I wanted to show y'all. So this was just grabbed off the beach. There was a bird there called a gannet, and he was actually dead, which I felt terrible about. But these were some of his pretty feathers nearby. And and they all, and then this is a little, just a little pretty considerate, but not too exciting. Okay, this is a cool business here. So these are the ones that I'm keeping, and I'm gonna spread out the ones that you can take if you want. But know that if you want it to be tumbled, you're gonna have to remember what it looks like. And when they're tumbled, I'll give them to you. But it's gonna take weeks for that, right? So a couple things you need. That's a granite, obviously. High silica, low silica, you tell me. High, because it's light colored, right? All right, this is my favorite one. I'm gonna get it wet. Because, whoops, I'm gonna get it wet. You can really see color. These are way cool. This is my favorite because it's green. It's green, and I looked them up. This one is super green. This is serpentine, I think, inside. This is my other favorite one. But it's got a huge green vein, and it's got a darker green underneath, which is very cool. So these are all the ones that I've collected that I'm keeping. Look how shiny these were. These are like total glittery. This one These right here were super interesting. This is all siltstone or sandstone, some of it's a mixture. And I picked off a gigantic block of this and picked it apart painstakingly because this is where you find fossils. And I found nothing. I'm talking, I had a on the floor of my Airbnb and broke it all apart. And I was hitting it with a, what was I hitting it with? I think it was something heavy that I found. I don't know. And my husband trying to work and said, "You want this done?" I'm like, "No, just keep breaking stuff." So I got really white ones. This one, look at the micro content in there. So this one's similar to that. It's got less of the dark stuff. This one had a little of everything. So what kind of rock? This is great. This should be easy for all of you now. What kind of rock is that? This too. These are the same. You know what they are?
Rocks.
Sedimentary or metamorphic? You tell me. Metamorphic. Yep. What kind of rock has other rocks chunked in it like that? That's conglomerate. Yeah, that is conglomerate. Now this one was particularly interesting, and here's why. That red stuff is
What?
jasper. This one, look at the way the black and white veins are going. Now look at the way the red veins are going. That's interesting. They are crisscrossed, which is super cool. I don't know what happened with that thing. This is another really neat one. Look at that. So these are really neat. And I love this one. This one was clearly on the edge of the vein of quartz because it's got quartz split right down the side of it. It's like split. So these are super cool. So, oh, and this one, you're gonna see. Yeah. Fun. So these were fun. This one was super smooth. These are the sparkly ones. So I have some that you all can have. If you want, you can take them, or if you want, I'll give a little dip of water if you want to dip them to see them better. You can take them, or if you want to tumble them, I'll tumble them for you. But these are the, I carry these in my suitcase, y'all. Notes from Canada for you guys. I'll get a little thing of water if you want to. A couple of them are really big.
Looks like that one.
I had so much fun picking it out for you. I'm like, and my mother's going, "You're gonna carry that back." Oh yeah, this one's really cool. This one has that stripes.
Oh, that's supposed to be dark.
Yeah. Some of these are really green. Some of these are like, this one's clearly a conglomerate. This one's clearly a conglomerate. There wasn't really any good breath yet. This one's just quartz. It's a solid. We're stopping. You need some too. This one's been tumbled and tumbled and tumbled. And this is the crazy thing. It was tumbled somewhere to get smooth, and then it was in the wall of the side. There were a lot of smooth river rocks in that cliff, which is really fascinating. They got clearly moved from somewhere where they've been eroded for, look at this one, look. Look at this. That is really cool, right? These are super neat. But these siltstone ones that I got, it's like looking at big fossils in them. They can, a lot of them just break. See, yeah. I mean, I sat there and broke them for like an hour. Made noise. Like, you find something in here?
Those are ones.
Not used. I love it. Yeah, these are all pretty old. Yeah, it's a good news. That's serpentine in it. That's gorgeous. Oh, you got it? The same color. I love the colors of this. I got it. See, it looks like. Yeah, are you gonna remember what it looks like? There you go. When I tumble that too. Yeah, it will come out glossy. Yep, it'll take a couple weeks now. Take a picture of it, see what it looks like. And you're right. Because I'm gonna tumble a lot. Okay, if you want to tumble, just like we can right to your. And I reordered it, so it should come in. Cool, you got it? You know the shirts? There you go. There you go, because it'll be glossy when you get it. Got. Very cool. This one was just, look at that. The green serpentine right here.
I like how it like kind of almost like
Yeah.
different.
And then it got another layer, yeah, and then you can see it kind of broke from here, and then it's all this jasper mixed in with the quartz. It's just super cool. My mom does not.
Picture Freddy.
Walking along the beach, just like grabbing every rock I could find. I looked like a crazy person. Had a big conversation with a dead bird. I did. I was like, "I'm so sorry, you're dead. Are you you giving up any of your feathers? Oh,
Oh, wow.
one beach.
That's so cool.
Yeah, I like it.
Yeah.
It actually kind of rubs off a little bit. So, yeah, so look. So sparkly that it just chips off. That was beautiful. Did you get your water too? Get water, Sid. I got it. You good? Okay, cool. Very cool. So whenever my tumbler arrives, my second tumbler, I mean, it was not, this thing was brutal. Completely brutalized. There you go. Cool. Awesome. Yeah. Very cool. Yeah. Good to see you again, sweetheart. You should come hang out more often. Freddie. She's like, if you like pretty pictures, this is one of my favorite. No, it's not. It's just a long, so that's how we're gonna eat, right? Yeah. Yeah.
Hello? Hello?
All this picked up and moved and dumped, it's pretty cool. Some rain. Because, you know, I want to, they still look hot, I can look up. So these are Bob cranberries and we're growing wild outside of the city. I haven't heard of it. I got a whole handful. But like, I don't know, it's like they were big. They're good. That's long term too. That would be it. Oh my god. Hey, Red is almost unparalleled in what we're doing. Really good. So, oh yeah, I think like I got the rocks on front of it. You can see it. There's another one, about 70 years in a row, that's still on the way. See how, it's like around the break of the sea. It's so pretty. Ready? Go. Ready, come here. Come on, no, both hands go. Well, okay, now, okay, now I get it. Okay, let me go. Oh, the same beach that I got the group of was actually the location of the first transit line, people. Because we were going to, they still have some years in one. This is a big old chunk. Look at this big chunk right here. So it's gonna have to be all the right. I think it's a park because I find them in the I can actually see other things. I didn't know how everybody. So James, has the up people and our generated to the family. Checking out various. Some of us, well. So we're gonna get waited for our coach to go on vacation and then we all just left it. The truth is, the administration is not great. They waited till we left to start a fight. And we were like, okay, fine, they made it pretty much impossible for us to say, the fight they started, we're not. And Mario was wanting to restart their next meeting. And that was being hired. Brian told me that, he was coming from Roswell. They was relaxed, and we got seated with a level, I would say, 6 or 8 coach over there. Oh, it's got been ready, so he came, and we're waiting on me, I don't know, what we still on yet. And they're building a brand new building, so we're gonna be. I can just find those, see if I can take it back. They're also, I mean. Okay. Here you go. I have your dog. Oh, look at that. Look at that. He thought it was no dog. So. I have to walk on, handed out the other side. We also wanted to swim little, river walk, and there were sea stars right there. And so there's one place for the shower, come back and beach now, and, alligator. And so I actually pulled on the river. Have a fire on them. They were kind of purple, and so I pulled my out. And, put them together, and there was this little piece of debris that was stuck to its nipple, and the little dude, it walked it out, like you could see it, ran it down its nipple, dragged it over. This is cool. Yeah, right. And it was in for an arm, this is the debris. Yeah, first time I was walking, it was spotted on me. It's fine. Scared me, I don't have movies. Die. You're gonna see a movie die. Those wild, I didn't believe them. They are. One minute. This one just was a second. But in practice, so you're supposed to go out and. So now we're. All right. Well, like, yeah. Yeah. Here. Here in front. It was like, oh, I can slide in the water. That's the big model. This is what we have to do. We don't directly get Anakin, want to choose, and then what? Here, your headaches there. Okay. Yeah. Hopefully, you know. You get stuck or whatever, you know, get. Goes on. You part with, I think, like, I don't know. My mom was scared of the water. I'll get that. Maybe it's about the book. It's start. I don't know. Report five, all day. I mean, like, I love her job. That's a long time. Thank you. I've seen there, I've seen like this, on the concrete bench. I'm seeing it and I'm big deal, and I'm checking my license for the partnership. And this man comes in. On the phone. He was, my phone was there, and I was like, oh, now I'm worried about it would be. I feel like it was a lot, right? And I'll get to the little. It's not how we're in one place. Thank God. For not.
Ozzy Hush.
So, he was like the last one. God, so, Candy, Carol, I just. Yeah. Oh, no. Yeah.
So if they didn't read, this is right on the street.
Yeah. What? That would be really bad. Yeah, that's pretty. That's it. I like the gym. Yeah, it's really fun. Yeah, it's really, really good. It's the way that it works. Slowly, heat the hot water slowly so that it evaporates and get, I don't know where the change, you have fun. Here's, reading the one in the class. They're in the, go into teacher meeting in the class. They're there, reading always go to the channel. If you get the channel, you guys are. That all of them say, the website, your class name and all of it. Hey. So the plate. That'll be done. Oh, I didn't turn this off. I hate when I don't turn off Zoom. It goes for a year and a half. So silly. Liam's probably